Okay, in today's lesson, it's actually day 3, we're going to be talking about hyperbolas today. So this is day 3, hyperbolas. So, passing this. So we're going to be graphing and writing equations of hyperbolas. Let's just talk about the names of the axis. Hyperbolas is that happy and unhappy parabola. It could look like this, the hyperbolas, or it could be going this way. And there are different axes on these things. So the transverse axis is the axis that passes through the two foci, and then the other axis is perpendicular to the transverse axis, and it's going through the center. So let's take a look at that piece of paper again to write the equations for hyperbolas here. All right, so here is one where the transverse axis is the x-axis because it's going through those two foci. So this is the transverse axis. And then the other one is the conjugate because it's perpendicular to the transverse axis. All right, so we have our center again, H, K in red. We have our vertices, which are the blue dots. And that's going to be, again, that A distance. And we have two foci again that are in those vertices, and that's going to be that C distance there. The only difference with the equation here, which I have highlighted, is that it has a minus attaching the two of them. So when the transverse axis is the x-axis, that means this is going to be coming first, the x, with the a squared underneath, and then minus y minus k squared over b squared equals, again, still 1. And the other new thing is it has the actual Pythagorean theorem to figure out that b value. There are other things on here with the dotted lines which we're not going to need to cover for pre-calc standard. So here is one type of hyperbola equation, okay, going to the left and to the right. Then we have our second type, which is the happy face, unhappy face together hyperbola. The transverse axis this time is the y-axis. Here's the transverse. And then this is my conjugate. I have my center again in red. I have my vertices again in the blue, A distance. I have my foci, distance of C. Here the only difference is because the transverse axis is the y-axis, the y is coming first here. Again, it has the minus equaling 1. And again, we're going to be using the Pythagorean theorem to find b squared. All right, so let's take a look at our first example. Find the standard form of the equation of the hyperbola with foci at. So here are our foci and our vertices. So I'm going to plot them to see which axis this is on, which is the transverse axis. All right, so here I have them plotted. So now I can see my vertices and my foci going to be inside them. So if you notice here, my transverse axis is going horizontally, so it is the x-axis. So that means I'm going to be using the equation of x minus h squared over a squared plus y minus k squared over b squared. Oh, that should be a minus, my bad. Minus, sorry. Equaling 1. Okay, so let's get our A distance, or let's actually figure out our center. How am I going to get this center here? Think about it. It's got to be in the middle between these vertices. So these vertices are 4 distances apart, right? So that means it must be right about here. So that is at 2, 2. Yes, 2, 2 is my center. So that's my H and my K. And my A distance, again, is from the center to the vertice. So my A distance here is 2. Oops, 2. My C distance, right, is from the center to the foci, is how many boxes? 1, 2, 3. So I'm going to be using that equation here because I need the b squared for my equation. A squared plus b squared equals c squared. So let's plug that stuff in. Okay, so when I plugged everything in there, I get it to be 4 plus b squared equals 9. Well, 4 plus what is 9? Well, that b squared is 5. So now, let's go ahead into our equation. So x minus My h was 2. A squared was 4 minus y minus 2. My b squared is 5 to equal 1. So here's my standard form of that information that they're giving us. Okay, find the standard form equation of this hyperbola. Well, this is pretty much a hyperbola, except it has to equal 1, right? So how am I going to make this equal 1? I'm going to take the 16 and divide the whole equation by 16. So when I do that, I get it to be x squared over 4 minus y squared over 16 to equal 1. What is the center of this ellipse? 0, 0. And then I could go ahead and graph things if I needed to find the vertices and the foci, but they're not asking us to do that. Okay, we're going to now do another completing the square here. It says sketch the hyperbola given by. So remember, step 1 is the x squareds and the y squareds on the left. And then if there are any numbers, that's going to be on the right. So if I take a look at this lovely thing here, 16 has to move. So let's organize this. So it says 4x squared plus 8x. And then minus 3y squared to equal negative 16. All right, step 2, we want to factor, so it's 1x squared and 1y squared. All right, so this one over here, I have to factor out the 4. So I'm left with x squared plus 2x. This one over here, well, there is no y with the y squared, so I don't need to factor anything out because I can't complete the square for that one there. All right, step 3 is to complete the square. Take my b, divide it in half, and square it. So my b over here is 2, divide it in half, squared. 1 squared is 1. So I'm going to be adding 1. So I got 4, got x squared plus 2x plus, and that's going to give me a 1. Bringing down the rest. Now, what am I adding over here? Well, it's not going to be 1, right? It's going to be 4 times the 1. So it's going to be 4 there. So now let's see what we have as a result. So I get 4x squared plus 2x plus 1 minus 3y squared to equal negative 12. Step 4 now is to factor. So let's go ahead and factor this trinomial. What factors of 1 add up to 2? So it's x plus 1, x plus 1. Let's combine it so it's as 1. So it's x plus 1 squared. So we're almost done here. We got our x squared and y squared on the left. We need to make this equal to 1. So let's divide by negative 12, negative 12, negative 12. All right, here's a little tricky part here. So 4 into negative 12 becomes negative 3. And then negative 3 and negative 12 becomes positive y squared, and the 4 is on the bottom, to equal 1. Now, this is not the correct way to write this hyperbola equation, so I'm going to flip it because this negative means that's where the minus should be. So it should say y squared over 4, then minus x plus 1 squared over 3 to equal 1. So this negative here became that minus sign. So here's my equation for this hyperbola. Okay, the last thing they want us to do is to sketch this thing. So let's say our center here, our h is negative 1 for the x, and the y is 0. My a is 2, right? My b is root 3, which I don't even need. But let's figure out the c value. So a squared plus b squared equals c squared. So I got 4 plus 3 to equal c squared. So 7 is c squared. Okay. Okay, so I get it to be root 7, which is about 2.6. So I just plotted, oops, no, I did not. I just now, let's see, fix this. So my center is negative 1, 0. Okay, since the y came first, I know that the transverse axis is the y-axis, so I'm going to be counting up and down. So my foci is going to be going 2 up. Excuse me. Yep, 2 up. So my vertices, not my foci, because the A distance is my vertices, is here. So here's one vertice, and here's the other vertice. Right? This is my A distance, which was 2. So let's actually make this now. Here goes one, and here's the other one. The only thing I need are the vertices, which is a distance of 2.6. So it's about 1, 2. Let's say this is 3. So 2.6, let's say, is about here. Here's focus 1. And then here's -3. Let's say about here is focus 2. And there you have it.